one of the greatest things about object-oriented programming is that we can leverage our objects or our classes. That way, we don't have to repeat the same classes to create other classes. So there is this concept called inheritance, which allows us to inherit or mirror other classes, right? That way, for instance, if I know that one class has the base properties as well as behaviors as the one class that I want to create next, I can inherit those properties and behaviors and still add my own behaviors and properties if need be. So let's look at this class, right? Very similar to what we have created. It's a car class. We pass in our first constructor here, primary constructor, color and model, and we could pass as many as we want, right? We have some functions, some class functions, speed, and we have drive. Now imagine that we want to create a truck. If you think of a truck in a real world is a car in a way. So if I said truck has common attributes and behaviors. So in this case, truck could inherit from car. Okay, just as an example. This concept in programming is called inheritance. So we're going to inherit properties and behaviors of our parent class. In this case, car would be the parent class and truck the child class. Let's go ahead and take a look in code how this would work. Now, before we move forward, I still have our class car here. I want to show you something. Every class that we create in Kotlin actually inherits from a class called any. If I go like this, I'm going to say colon to say that inherits, and I can say any. What is any? Well, any is a root of Kotlin class hierarchy. So every class has any as its superclass, as its parent class. But because, as it says here, every class inherits from any, we don't have to specify any whenever we create a class because it is already implied. I have something that you may have observed. So you notice that before we said something like this. Whenever we wanted to create, let's say, a variable, would say val or var. I'm going to just use val because that's usually the recommended way. And I'm going to say name. What we do is, in fact, you see here it says name string. I hit enter. I can say colon string. What does that mean? Interesting. This, you may have imagined, it could mean, I'm not sure, it's just speculation here, so to get you thinking, it could mean that name as a type, it's actually going to be inheriting from the string class. Is that true? If you hover over, you'll see this is a public final class string. Interesting. That means then when we are creating variables and creating the types of those variables, string in this case, that means that we're inheriting from string. So name now is indeed a string. That's why we can say name as such in dot, and we can access all of these methods. These are methods that come from our string class. Now let's say command click, or in this case control B for Windows or Linux. You can see that's what it is. Now this can sound very daunting. It's a lot of code that we may not understand. But one thing I want you to look at, it says public class string. Of course, inherits some other classes there, but that's not a problem. But look what we have here. We have a few methods or functions in this case, right? We have public, operator, fun, plus. All of these functions and overrides and so forth, we'll talk about those. All of these are available to us because this is a class, and if we inherit from this class, that means we have access to that. Plus, length, get, subsequence, compared to, we can access those if I say name, because it is string, as we said. Say plus, you see there is plus, there is toString, there is length, there is get, and many others. Okay, compared to, and so forth. So these are methods that come, of course, with our string class. That was something that I want you to think about. All right, so let's go ahead and create yet another class here. Class, call this truck, like this. Now, if I want truck to inherit from car, I would have to say colon, say car, like that. Now we're going to have an issue. If you hover over, it's going to say, well, change the constructor invocation and also make, so there's a lot of things here. say to add constructor and make car open. The first thing we need to do is all classes in Kotlin are closed, quote unquote, meaning we can't really inherit from them. So we'll have to say open like that for it to be able to, for anybody to be able to inherit from that class. If you have over, you will see that we no longer have that issue, right? Because the class is open. However, we have other problems because here it says we need to change to constructor invocation. Let's click here and see what happens. Aha, and there we go. We still have a problem. Hover over, what's going to happen here? Add constructor parameter color, and we continue doing that. But let's go back to what we really want to make sure to do. So truck, we're going to create a constructor, right? A primary constructor as such, and then we're going to just say inherits colon from car like this. But the problem here is that when we inherit the truck from car, as you see here, let's click here, we're going to say we will have to add constructor parameters from car string because we are inheriting from this class car, which contains these two parameters. Okay, so I'm going to click there, and there you have it. So now truck will inherit from car, but it will have to, when we inherit from car, that means we have to, of course, have to get and pass along the color and model. So check this out. I'm going to come here, say truck, val truck is equal to truck like this. And you can see, of course, we have to pass color, magenta, what a beautiful color, and a model, we're going to say F16, I think, something like that. I don't know a lot about trucks or cars, but that's fine. We're just trying to figure things out here. All right, and once I print, now that I have my truck, I can say truck like this, dot, and I can invoke drive and speed, as well as model and color, because we have inherited from car. Notice in our truck class here, close this down, we don't even have a body. We don't have a body. We could put something, but because we are inheriting, we could just not have a body. In fact, actually, a class could just not have a body, and that's totally fine. And we'll talk about data classes and so forth. But in this case here, notice that I don't have a body where I'm actually creating or have created speed or drive. Yet I have access to drive, speed, model, color, all the properties, and the behaviors. Okay, that's real good. So if I say drive, for instance, what's going to happen? I'm going to run. Okay, so we have magenta is not green. Ah, right, because we have this initial init block there. Let's just comment this out. That's fine. It works fine. And it says here drive vroom. However, this drive vroom here is indeed drive vroom, the same drive vroom from our car. What if we wanted to make the drive to be a little bit different in this case, because the way a truck would drive, we can assume it's going to be different than the way a car would drive. How do we do that? How do we customize this truck so it actually becomes its own entity, even though it inherited all of the properties from our car class? Well, there's this concept called overriding. So I'm going to put a body here. I'm going to say override like this. Okay, what is that we're going to be overriding? I'm going to override the speed function. Now, we have a problem here. When we override, we should be overriding what already is there. But we have no access to speed to override it, because when we inherit, we actually have to also say open to make sure that this is accessible for us to override. So let's go back here. I'm going to say override fun speed like this. If you hover over, it's going to say change function signature to fun speed right, because that's what we are supposed to pass. Okay, min speed, max speed. And I can also go and override another function. But is that going to be possible? This drive, which is the one that I really want to override. We're not going to be able to override this because, yes, you guessed it, we have to say open for us to be able to override. So I'm going to say again, override. Ah, now we have options there to just click override like that. Now something happened here when we use our code suggestion here. It's called super.drive. What is this super? Ah, if you highlight super, it's highlighting what? Car. Super, in this case, it's calling the super class, which is the parent class. It's saying here, initially, if we don't change the behavior here, it's going to go and call the super.drive, the method from our car, the parent class, which in this case is not what we want. What we want is to have our own. I'm going to say print ln and say vroom, like this, like a truck. Look what's going to happen. If we run this time, remember before we just had drive vroom. This last one is indeed from our truck object. Okay? I'm going to run this once again. You'll see the difference. Aha! Now, when we say truck, we create the object truck. We invoke the drive method or function. What's going to happen, it's not going to go ahead and call this drive method function here. We are going to override it. That's why we have this keyword override, the function, and it's going to call its own truck function inside here. It's going to call this vroom like a truck. And this, my friends, is revolutionary because now we have a lot of flexibility of what we can do. In fact, we did that with drive. We can do the same thing with speed. I can just say something like this: print ln full speed is equal to min speed times max speed, something like this, just to be a little bit dramatic. Truck full speed, and I'm going to say full speed as such. Now, if I come up here and I say truck dot full speed, or I said speed, right? Pass the minimum speed like that of 20, okay, and max speed of 90. What's going to happen? Let's go ahead and run. It's going to say vroom like a truck, truck full speed 1800. And of course we still have car information and everything. And there you have it. So we, in this case, we inherited from car, but most importantly, we've changed a few things. The behaviors of our truck should obviously be different from the behaviors of our parent or superclass car. Okay, as another exercise, think of a real-world example that you can use to create this inheritance, this connection, right? So always think in terms of nouns, right? So you could create a class called book, have properties and behaviors, and then you can have a magazine inherit from book, because really a magazine is a type of book, if you will. All right, go ahead and give that a try, and I will see you next.